might want a calculator. I don't think you'd be okay without it, Brandon. Okay, I'm gonna take those out though. Get a pencil. M2-9 is what I said. Yeah. Everybody a chance situated?
What do you do if you have my 6th period is a quarter class, so I don't think I'll have time to go over it?
You should still have, depending on what classes, you should still have something in there.
Okay.
Even quarter classes do, it just is from the quarter to this end of the semester.
Okay. Do I still go to class?
Oh yeah, you still do. Just double check with your 6 hour, but you should definitely still have something going on there, Reese.
Okay.
Except your final one is open by October to December. Alright, one more time everybody. M2-59. Once we get done here with things, I know, again, I'm encouraging you to keep working through Matthew. We have only one more Matthew day here, but once we get done with our notes, I know Victor said he was stuck on one of these. If you are stuck on something, we've been happy to help you out on that. Alright, M2-59, let's do the warm-up here. Now this warm-up today is actually a good question for us in preparation for the finals. We want to determine if these order pairs are representing a function, yes or no. So as we look at these, let's go back to August, September when we started off with this. We were looking at these x values. It's where we start looking at to see if any of those x values are repeated. All right. So on that first question, are any of those x values repeated? Are they all different? All different. So what did that tell us? It's a function or not a function? Yes, that is correct. We have ourselves a function. Remember, x cannot be repeated. I cannot have another -1 up there going to 5 and going to 0. That cannot be a function. Second question is, you look at all those x's that are up there. Are any of those x's repeated? No, so we still have ourselves a function. Now, on the last one here, or the next one I should say, not huge of this, but any of those x's again getting repeated? Nope, we still have ourselves a function. So on those first 3 that we just looked at, what they started to do is change up the y's. But do I really care about looking at the y's? No, not really. Last one there, are any of the x's being repeated? Doesn't matter how many of them are repeated? No, it can be repeated once, twice, 3, 4, 5 times, who cares? As soon as you see -1 going multiple places, we say it's not a function. Okay, we did that back in August, September. And then over the last month or two, what function have we been focusing in on? We've been focusing on the linear function, right? And then second semester, we will spend a little time looking at the exponential function. So right now, let's focus on the linear function still. Let's flip it to the next page here. And on the next page, all right, what we have going here is our kind of 4 different views, okay? This is what we've been looking at over the course of the last couple months. We've seen it from a table, we've seen it from a word problem, we've seen it from an equation, and we've seen it from a graph. So those are the 4 different viewpoints we've been looking at. And what we're going to do here today is, depending on what you're looking at, I want to keep talking about 2 big things. Linear function has 2 big things. When we say general form, we've been telling you ax plus b. What's that a represent again, and what's that b represent again? A is representing what we call as the what? Slope, or the rate of change. And the b is called our, we want to make sure you guys can identify those 2 key features. If you can identify those 2 key features, then we're going to do some comparisons on things, okay? Now, let's go ahead here and talk about certain things. We're going to look at the table in just a moment. Those are pretty numbers to work with. It is what it is. But right here, I highlight that point again. Why did I highlight that point? What is that point called? From our table, when x is 0, this is our y-intercept. Now to calculate the slope, the rate of change, this is where you guys had to go through, remember, and do this, calculate the difference. All right, we're going to do that again here in just a minute with slightly nicer numbers. On the next one, it's a word problem. They haven't really given us a word problem here before where they said the ratio of boys to girls was 1 to 1. So what does that mean? If I got 15 boys in here, how many girls do I have in here? That's what 1 to 1 means, the same amount, right? So the equation of that, we haven't, bless you, it's the same. If X is the boys, Y is the girls, they're the same. So what does that mean? What's that slope? What's the y-intercept? The slope is right here. What number's in front of that x? The slope is 1. What's my y-intercept? If it was a 1, I'd see it. And I don't see it, it's right here. But because I don't see it, y, the y-intercept is correct. The y-intercept is 0. Okay? So we're going to keep identifying those key features. On the bottom one, we have an equation. You should be able to quickly tell me those two things now. What's the slope? What's the y-intercept? What do we have here? What's the slope on letter C? The slope is? And what's the y-intercept? I don't have it right there, do I? So the y-intercept is 0, and we said the slope was a fifth. Last but not least, let's go compare the last one. Let's go identify the last one. It's a graph. On a graph, the y-intercept's the quick one. Where is it crossing the y-axis at? The y-intercept's the quick one. The y-intercept is at 5. Now, how do we calculate the slope? It's not terrible, but we gotta make those steps, right? The rise and run. Okay, find a nice point. You told me the y-intercept was at 5. That's a nice point. Look along that line. Where's another nice point? I see a nice point down there. I see a nice point there. Look for nice points and then tell me how you go from one to the other. It's like giving directions home. Okay, how much do I need to rise? How much do I need to run? What are your eyes doing going up or down? So the slope should be positive something. Sorry about that. How much are we going up? Correct. And how much are we running? And is that consistent? Cool. And how will you finally write that slope? 1 over 5 or 5 over 1? And 5 over 1 just is 5. Sounds good. All that sounds good. If you can identify those pieces, you are great for today. We're going to go one small thing here in just a moment. Okay? I'm going to ask a follow-up question here on these last two at the bottom. Give me a second. You choose a different color. Oh, that's a C, not an F. What if I ask you C of 10? What if I ask you C of 10? What do we have to do? We have to plug it into our calculator, correct? We want to take 10 into 1/5. So 1/5 times 10, this is where our calculators come into play. And we type in 1/5 times 10. When you type it into your calculator, you all can do this without native calculator. We're just dividing. What's 10 divided by 5? 2, right? So the answer is 2. Okay, cool. We're about to do that again here in just a moment. And on the last one, this graph, let's go back to this graph here. Let's call this f of, excuse me, f of -2. Let's do this last one here. Remember, when this is saying when x is -2, where's the graph located? Where is that y value got to be? So when x is -2, where's the graph at? -2 is right here, go down, and the graph is at this next nice point, yep, which is -5. Oops, let me write that a little bit better. Now we've done all three of those things, right? We've identified the slope before, we've identified the y-intercept before, and the last thing we've done is plug into our calculator, looked at a graph before, right? There's nothing new there, is there? The only thing that's going to be new today is, and it's not even new, we're going to bring it back in, is use our comparisons. We're going to see how certain things compare from one to another. You're going to tell me it's either greater than, that's a greater than symbol, right? Or you're going to say it is less than. And what's the third option it could be? It could be greater, it could be less, or you could be actually equal to. Correct. Those are the three symbols we're gonna look at today when we do some comparisons. All right, it's nothing crazy. Let's go ahead and get crazy out and jump into it. We're not going crazy. It's pretty simple. All right, so let's go ahead and flip it to the next page, or maybe you're already on the next page. I got Victor still writing down. And on the next page, what do we have there? Table, a graph, equation. What do we have on the next page? We got a table and a graph. All right, let's do this, boys and girls. We want to do basically what we just did on the other side. Okay, down here, the questions that we want to get to in just a moment is do some comparisons, just like we did. We want to compare how does 0.5 compare to 0.5. We want to compare the y-intercepts. All right, and then we're going to use our greater than or less than or equal to symbols. Before we do that, let's take a look at what in the heck is going on here. All right, well, I should say we all, but possibly we are recycling at home. And whoever your recycler is, maybe up here it's what? Sanders, I think, is one of the trash people up here. Republic is another one. Waste Management, Aspen, whoever you got. Okay, they are collecting your recycle, and they collect it. They take it to a larger place, and then they actually get money for dropping it off. So, if you've ever collected aluminum, take it down to aluminum recycling, you sometimes get a few bucks out of it. All right, that's what's happening here. Now, for whatever reason, at the Washington recycling, they're showing their prices as a table. At Jackson recycling, they're showing their prices as a graph. And what we want to do is compare those two things. Who's got the y-intercept that's higher or lower? Who's got the slope that's higher or lower? That's what we want to do here. So let's go ahead and start looking at this. Okay, they pay out different amounts. We are doing what? Cardboard here. Washington lists its payout amounts in the table. Jackson does a graph. And the two centers' payout amounts are close, but not quite the same, not quite equal. So what are we doing here? We are recycling something. And in this recycling something, do they tell us? Cardboard and the weight and the money, right? So we have our weight for how much cardboard we're recycling. And is it in terms of tons?
Per
pounds? Tons? Where does it say per ton at?
The amount per ton. In the very first sentence.
Oh, where it says per ton. Thank you. Mosquito? Where I skipped over. So we are talking about weight. We're talking about tons of cardboard. Half a ton is quite a bit of cardboard. Half a ton is how many pounds? You know that conversion? Pounds and pounds and a ton? 2,000 pounds make a ton. So when we say half a ton, or if you hear a half a ton pickup truck, like that type of stuff, say it could carry 1,000 pounds, right? So what we do is we drop off 1,000 pounds of cardboard, and how much money we get for that? $7.50 for 1,000 pounds of cardboard. Does that sound like a great deal? Probably not, but when you keep going up here, recycling is not a money-making business. It just isn't. So what do we get in return? We can call that our, what's that? Earnings, is that what you're saying? Yeah, we can take earnings, you can call it just money. And what is our units for that? Are we in rubles? Are we in dollars? Yeah, we're definitely in dollars. Rubles, probably not very good. Russian. All right, same deal. We're comparing the exact same thing, but now it's a graph. One more time. Weight tons. Does that represent the x-axis or the y-axis? That's my x-axis. It's always that. So what do we have? Weight. And then that's in tons. And what are we doing? We are making ourselves a lot of money, right? Well, not a lot of money, right? But we are making money. So earnings. It's good to recycle, but people don't make money off of it. All right. Now let's compare things. Let's start comparing it. We labeled out, cool. Let's do number 2 now. We want to compare. We just did that a second ago, reviewing things. W is representing Washington. J is representing Jackson. Okay. When we say W of 0.5, what does that mean off of our table? For the Washington function, Washington's recycling, when the X is 0.5, what's its return? What's its Y value? 750. So I'm gonna write that just above, and I want to compare that to the Jackson recycling program. So now go look at the graph. When X is 0.5, what's the Jackson's at? Yeah, X is 0.5 right up here. This is 0.5 comma 10. So when I compare these two, now what are you going to say? How you can compare 7.5 to 10. 7.5 is, that's all you're going to do. That's all we're doing today, is getting those numbers and comparing those numbers. Okay. Now, of those two places at the moment, which one would you rather go to at the moment? Jackson or Washington? Probably Jackson. Now that could change as we keep finding some more information. Right now, Jackson seems to be relatively a little bit better, right? Okay, how about the next one? Washington, when we got 1 ton, how much is Washington giving us for a ton? We're going to compare that to Jackson for a ton. How much does Jackson give us for a ton? Go up, 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 up. Right here at 1 ton gets us a big old $20. Is Washington or Jackson better right now? Jackson's still a bit better, right? Washington is less than Jackson. Let's see if that trend continues. All right, how about 3 tons? Crap, I can't look at my table now, can I? Well, that sucks. Can I look at my equation anymore? Or sorry, not my equation, my graph anymore? That sucks too. So if I had that equation, we could do things. So let's go find that equation now, okay? All right, so off of here, in order to find our equation, we have to know what 2 things, the slope and the y-intercept. All right, let's do this over here on the side. Okay, this is going to be Washington's, ax plus b, and then we're going to do Jackson's over here, also ax plus b. Now, here's where I will give you nicer numbers on your quiz and tests. Okay, when I look at this, I get 0.5s, correct? That's not terrible, but let's look at this right here, from 115 to 230. Those are 2 nice numbers, right? 1 ton to 2 tons. How much did we increase by? $15. You can easily do that in your head, and this went from 1 to 2, which is a change of 1, right? So what does that mean? We are making how much per ton? $15. So that 15 is my slope, correct. Now, from here, let's also think about this. Let's just use some common sense. You drive to Washington's recycling plant, but you have 0 tons to drop off. How much money are you getting in return? So what does that mean? The y-intercept is 0, 0. You're not making any money there, are you? All right, so we put plus 0. There we go. So there's Washington. Let's go do Jackson's equation. Okay, Jackson. Same deal. We're making that, we're doing that the rise and run here. Let's go find some nice points. There's a crap ton of those. How much you going up and over, up and over, up and over, up and over. Okay. Now here's the thing though. We got those 0.5s hiding again. So what I'm gonna do is kind of, I don't want to say cheat here, but I'm gonna be smarter about things. I'm going from 0 all the way over here. Why did I go up all that amount and jump over all these right here? Start off at a nice number at 0, 0. And then I went to the first nice number of what? 1, 20. That's easy to do. How much did I go up? From 0 to 20 is 20. And how much did I run? From 0 to 1 is, how do I write that up? 1 over 20 or 20 over 1? You go to Jackson. You've got 0 cardboard to drop off. So how much money are you getting? You're getting 0. So now, we got our 2 equations. Cool. Let's go back to letter C. W of 3, J of 3. When W right here, when X is 3, is 15 times 3. 15 times 3 is 45 bucks. And Jackson, what's 20 times 3?
60.
So Jackson's giving us 60 bucks, right? So is Jackson still the better deal? Yes, it is. Okay. So all I'm going to do on my quiz and my test is I'm going to have it look exactly like this. And in between here, you're going to have the drop down. And what you need to do is select the less than symbol, the greater than symbol, or the equal symbol. That will be it. Get those numbers and compare them. Let's get those numbers on the next one for the y-intercepts and compare them. What's true about the y-intercept for Washington? And what's true about the y-intercept for Jackson? 1 is at 0 because you turned in 0 cardboard and you are making $0, right? Jackson, do they give you any money for 0 cardboard? No, that make no sense. So what happens to my comparison here? Less than, greater than, or the same? The same. Duh, that kind of makes sense there. So, oops. You're going to select from the drop-down menu on Thursday and on test, less than symbol, greater than symbol, or equal symbol. You got to know though what in the heck you're comparing. That's what we're working on today. Okay. We haven't done anything different than what we've done before. We've done all this work before. We're just now comparing these last 2 bits. Okay. When the heck am I ever going to use that? Well, it is comparison of things. If you like shopping at this one store, but this other store is the other one that you go to, which one's got the better deals? Would you rather have a better deal? I would, right? So that's what I'm doing, seeing who's kind of got the better deal out there. So who's got the better deal? Washington Recycling or Jackson Recycling?
Jackson.
So let's go to Jackson. All right, let's flip it. Let's go to the next one. All right, what do we got this time? We've got ourselves a table, and we got ourselves an equation, right? Okay, on this here, as you read through these 2 things, you've got Greg and Josh in different parts of the country. We are weird because we don't use metric, all right? So one's in Celsius, one's in Fahrenheit. Now, we're just going to fill this out and compare things very nicely here, all right? What we want to do is, right here, compare the given characteristics for each function in terms of the quantities. So we want to get the slope, compare the 2 slopes, and then we want to get the y-intercept and compare the 2 y-intercepts, okay? So for the slopes, who do we have again here? Greg and Josh. So the Greg's slope, we're going to get that, and then we're going to get Josh's slope and compare Josh's slope, okay? Now, of those 2, Josh's is the easiest to look at and find. Josh is an equation. You should be able to identify that slope just like that. So what number there represents the slope? 9/5. 9/5. So that's an easy one to identify. 9/5. The one's not as quick to identify is the slope coming from the table, correct? So off of there, like I said, we'll give you nicer numbers. But for today's sake, we're going to do, I'm just going to cheat here with it and just give you the slope, which turns out to be 5/9. Now how I did that was again using what we've done before, this change like we've done, but I'm going to give you nice numbers to work with. Okay, those are not nice numbers. Now here's the thing, we got to compare 2 fractions. How does 5/9 compare to 9/5? 5/9 is what? 5/9 is less than 9/5. Now, if you're not sure, change it to a decimal. We could go to our calculator and take 5 divided by 9, which is point, what, 5 repeating. And then I can go to 9/5, change that to a decimal, which is 1.8. That's a lot easier to usually see, okay? So, there we go. Now let's do the same thing for the y-intercept. Josh's is quick to find. Look at the equation. What's the y-intercept for Josh? I'm sorry? 32. The table, not as quick to identify if they don't have 0 up there. Is x 0 up there? No, unfortunately, it is not. So, I will give you that 0 off of there. I don't know what that 0 is off the top of my head. Negative 17.5 is Josh's. So if I gave you that nice point, and what I mean by I give you that nice point, I'm going to write it in the table, and I'm going to have it like that. And that is code right there for y-intercept. So how do we compare negative 17.5 to 32? Negative 17.5 is less than 32. That's it. Get the two things and compare them. You're going to have a drop-down menu in between. That's all we want from them. Okay? All right, let's go ahead. Let's do one more here. Let's flip it. And what we asked last part doing, we're doing a graph and a word problem, right? So let's finish this dude off. Let's get the slope of DeAndre and the y-intercept of, well, we got Michelle and DeAndre here. And let's compare the two. DeAndre's slope, and then let's compare that to Michelle's slope. Okay? All right, slope, slope, slope. Rise and run, rise and run. How are we going from point to point to point to point? All right? Yep. We're going, what did we just say? Yeah, we're going up, to, and right. Let's see if we can get off with that, though. Yeah, we got to first look at this, though. We can't get off of that. We have to first look to see our x and y axis, though. Let's reverse that, too. Because they did not give us the scale here, we don't know what that scale is doing. So unfortunately, we need to go back a little bit more closely at what the scale is. DeAndre's account shown in the graph below. He started off with $0 and deposited the same amount each month. So he is right here at 0, 0. He started with 0, 0, and then the fourth month, he had $80 saved. So first month, second month, third month, and then fourth month, he had 80. How do I get this up to 80? What is the best to go by? 10, 20, 30, 40, 50, 60, 70, looks like 80. So it looks like we need to make the y's go by what? Tenths right there. Same deal. I'm not going to have you go through and figure out that scale. If I ask you to compare one online, I'm going to give you the scale already completed. You just now need to calculate the slope correctly. All right, let's do that again here. Let's try this again. We went up 2, which is correct. But because our scale is going by tens, going up 2 is actually the same thing as going up 20. Then I turned to the right, and when I went for my run, but take a look at it, I went from 1 over to 2. How much is a change from 1 to 2? It's a change of 1. It's because my x's is going by 0.5s. And how do I write that up? 1 over 20 or 20 over 1? Correct. So what that means here is DeAndre, he's putting in $20 a month. What's Michelle doing? How much is Michelle putting in a month? Yep, and she's depositing 25 each month. And how does 20 compare to 25? It's less than. Somehow they've managed to give questions that all are less than. Somebody didn't check these very nicely. The y-intercept. Let's go do DeAndre and Michelle's y-intercept. DeAndre's y-intercept, and then Michelle's y-intercept. How much did DeAndre start off with, it said? $50? No, it said start off with 0. Okay. And how much did Michelle start off with? $30? No, 25, right? And how's 0 compared to 25? Less than. So I'm just looking at less. I promise you on the quiz and test, they will not all be less than. They will have a combination of everything. Okay. All right, let's do one last one here. I'm gonna add in a last question down here at the bottom. Let's compare DeAndre here. He's gonna be capital D. Let's do D of 2. And let's compare that to Michelle. And we're gonna compare Michelle's as well. Okay. So D of 2 compared to M of 2. So when we say D of 2, that means go to DeAndre at month 2. How much money did he save? 2 comma what? Where's the graph at? 2 comma 40, thank you. 2 comma 40 is where DeAndre's at. He's comparing 40. Now Michelle, you just told me everything. You said Michelle starts off with $25 and then increases by 25 each month, right? So then the second month, how much? Plus 25 gives me 50. So how does what? 40 compared to 50? There you go. Okay. That's the 3 things we're going to ask you. Slope, y-intercept, and an evaluation. Call it a day, call a lesson, and now we can call it basically a semester. Okay, that was essentially our last lesson of this semester. All right. Don't get too excited there. Now, Ms. Kino's gonna get the assignment out here. Let's do a few of these together. Get you set up. Aiden back there. Make it quick. Ari, when she's back, and Zale when she's back. You all in order. Okay, Ms. Kino's getting out the assignment here. I'm gonna get mine pulled up. Let's take a look at what the quiz and tests is going to look like. You're going to have some of these questions on your final as well. So let's go ahead and talk about what we're about to do here. As always, we'll do a few of these together. What we don't do together, you're going to finish up, and then you're going to do it on Matthew as well. Making sure Matthew is again completed on 2, 3, 4. If you are stuck on something today, this is the time to ask it. There's a few of you I need to get onto. Because you've had some time and slow step package unit 3. So let's look at the assignment here that is in front of you. Alright, let's do this, boys and girls. Come on, Brad. Let's go on the book. Alright, let's take a look at number 1. When I look at number 1 here, there's a typo that I just noticed. Put an X right there. That should be an X right there after the negative 3. Negative 3x. Okay, we got ourselves an equation to look at. When I look at that first one, what's the slope there? Slope is what? 2, and what's the y-intercept? Those are quick answers. Let's go. What's the other one? The slope is, and the y-intercept is? I do not have to do anything there besides just look at it, correct? Now the next question says, based off that, let's compare the 2. The slope of f compared to the slope of g. 2 compared to negative 3. So that's what you need to do on that test and quiz and the final. Get that information, then compare 2 to negative 3, and that is, yep, greater than. You're going to select greater than from the drop down menu. How about the y-intercepts you just located? Negative 3 compared to 5. And the order definitely matters, so make sure you read it carefully. It says the y-intercept of f and g, and that is less than. That's all we basically just did today. That's what we're going to look at. Can't make it any straightforward than that. Let's do another one here. Let's look down below. All right, let's do number 3 here. Number 2 is pretty straightforward. It's an equation and a graph. Let's do number 3 though. We got a table compared to a graph. The table is called f of x. The equation is called g of x. Let's identify these pieces and then
Girls in the back, stop
compare them.
talking.
Okay, f of 16. F of 16, look at the table because that's the f of x table. When x is 16, what is my value? 16 comma what? Comma, yeah. When x is 16, what's my y value? It is 0. I want to compare that to g of 2. So I go over to the equation. I plug in 2 for x. We've done that before. And this is where you're going to take your calculator and punch that in. It's pretty straightforward. 0.5 times 2 and then minus 8. And what do we get? Should be getting a. Now compare that to there. How does 0 compare to -7? You're going to select from the drop-down menu. That's it. That's it. Let's look at the slopes here. Okay, the slope for the table. I said a few minutes ago I will give you nice numbers to work with, and that's what I just gave you. Okay, these are some nice numbers to work with. We only need to do one of these. This is a linear table. I just need to know, how do you go from -16 to -8? You going up or down? We're going up. How much does it take to go from -16 to 8? We need to go +8. How does it go from -16 to 0? Are you going up or down? And how much does it take you to go from -16 to 0? And how do we write that slope? 16 over 8 or 8 over 16? Reduce it down. I'm going to give you nice numbers to work with. 8 over 16 reduces down to, not 2, 1 over 2, right? You're doing 8 divided by 16, not 16 divided by 8. Okay? I want to compare a half. The other one is quick. Just got to look at that equation, you got it. What's the slope there? 0.5. And how does a half compare to 0.5? I say that isn't equal to, obviously. Well, it should be obvious. So you're going to select from the drop-down menu the equal sign. That's it. Identify the pieces, compare. The y-intercept is our last one from the table. Again, we've been talking about it. Y-intercept from a table, x has to be 0. Do I see that on my table? I've been circling them. I've been writing it to say, hey, when x is 0, the y-intercept is -8. Equation's quick. What the equation is, what's the y-intercept? Yeah, and also -8. The y-intercept is darn quick from there. So, how is -8 compared to -8? That's it. That's what we talked about today. That's what we want you to do tomorrow and the next day on the quiz, the test, and the final. And that's what the Unit 5 is, a math. Yeah. This is a comparison there. Okay. Now, from this point on, what's that rest of that stuff look like? New stuff or old stuff? That is all, yeah, that is all old stuff, as you can tell. It's our transformations work. So let's do a couple of those right here, just to get you prepared for the quiz on what? Thursday? All right, so let's look at this here, all right? Let's take a look at number 5. So just reviewing from what we did last week. You guys started to do pretty well with that on the last week's stuff. I'm giving you f of x is 2x. And then I want to transform it, as stated right here, as f of x minus 6. So what does that transformation going to do? Is that going to be then increasing or decreasing things? What's that going to look like? So what's a minus 6 do? It's at the end. What's a minus 6 do at the end? Yeah, it either moves either up or down. And it's going to move it down. Now, what do we start off as? The slope is currently positive 2. And all we're doing is what? Taking it and moving it down 2. So what's that slope doing? Is it staying the same or is it changing on us? The slope is still 2x, right? I'm just moving it down 6. And when it's positive, the slope is increasing. You're going to select that from the drop-down menu. Okay? That's it. All right. How about letter B? You want to take the original and multiply it by 5. When we said you're multiplying by 5, that is out front. We say that's either a vertical dilation, and we say it's either a stretch or a compression. Bless you. When we multiply by 5, we're taking that rubber band and stretching it out. So we're going to take -3 times 15. What's -3 times 15? Yeah. So that new equation is -15. Took the original and stretched it out. Because you multiply by something, you're doubling it, quadrupling it, tripling it. Whatever 5 is, I don't know. Quintupling it? Sure, let's go with that. And what is that graph doing now? Increasing or decreasing? It's still decreasing because the slope is still negative. We just basically talked about that stuff above too. Okay. That's the stuff we did last week. What else did we do last week? Flip it. Let's take a look there.
Can you go back for one
Sure,
second?
I can go back one more time.
I think on our.
Is it a different file? You guys have the same numbers there or no?
Okay, no, maybe.
Oh, okay.
My other class had different one. I was like, how are you getting that? Okay.
Oh, gotcha. No problem, Scale. All right, on the back side of things, we look at number 6. A lot of crap going on there. So let's answer it one at a time. Okay, I'm starting off with that x value. F of x equals x. We transform it, and then there's our transformation. Let's look at what each piece is. That's what Unit 4 just did on Matthew for you last week. Okay, the original graph, that's the red one. Right now, what is that slope doing? Is it constant, increasing, or decreasing? It's increasing because the slope is positive, right? It's +1. +1 increases. Then we transform it. Is that going to change on us? All right. First thing is, like you did on Matthew, is this thing moving up or down at all? And the reason why it's moving down is which number impacts that? The 4 does, correct. And at the end there, you guys selected a vertical translation down 4 units. Then other things that were happening on that Matthew, it was either getting compressed or stretched, we said. And the other number out front influenced that. I don't care about the negative, but it's a 3. And what does a 3 do? Triple something, so that does what? Increases or decreases it? It stretches it, right. Take that rubber band example. We're stretching out that rubber band. And then that 3 is what we say is by the factor. Okay? We're tripling it. And the other thing that you did on Matthew was potentially a reflection. Okay? How do I know if there's a reflection happening here or not? Well, out front is a negative. And when you have a negative out front, that means we have a reflection happening over the x-axis. And when we reflect it, take a look at what we did to answer up above. We said originally we were increasing, and when you apply that reflection, you go from increasing now to decreasing. So the final transformed graph turns out to be decreasing. Is that new? Absolutely not. And I know Matthew on Unit 4 slammed you on that type of stuff. Okay. If you're stuck on some of that Matthew Unit 4, you'll have some time here in a few minutes to ask about. And I'm going to talk to a few more of you because some of you need to get on the ball here. All right. Have we ever done 8 and 9 before? Hell yeah, we have. All right. We've done a lot of that before. Okay. So let's take a look at number 8. Let's finish this off, and you guys can do the last ones there. What are we doing on the last one? We're not selling anything. We're buying stuff, right? We're buying cans of tomato soup. Anybody like tomato soup? No? Okay. I can take it or leave it. All right. C is representing the number of cans, correct? And here, this is representing our T for correct. So you're buying cans of soup. You're not feeling well. Cans of tomato soup. You're stocking up. And how much are we paying for these cans? 75 cents a can. How many cans did you buy? Do we know? No, but all you know is it costs you how much per can? 75 cents. C, right? Let's label it. We just did that to in our notes, as you should be able to tell us. Everything has come full circle from August until now. We have cans and we have costs. Which axis represents what? X-axis is what? Is the cans, correct? And the cost is the y-axis. been the case every single time. Money's been on the wise. That's what we've been doing. Now, identify the point that represents $3 worth of tomato soup purchased. So where's that 3 located? Okay, here's your cost. You bought $3 worth. Go find my graph. This is right here. So how many cans did you purchase? Yep, already saying you what? Bought 4 cans and paid $3. Look at your axes. You're all smart there. Look at your axes. Go to the cost and then find the cans down below. Now, what we got top here? You really like tomato soup. Okay, so what's letter D say? Bought 10 cans and paid, how much is 1 can? But you bought 10 of those. $7.50. We use our calculator. We use our equation. We've done that. We just did it a few minutes ago. You plug in that 10 for C and plug it into your calculator, and we paid $7.50 for tomato soup. Now, let's say you're doing it for maybe a food bank, something like that. You've got a $100 donation. You're gonna go buy. You're in charge of buying the tomato soup. How much can we purchase with $100? We're not plugging it in at the same location. This is our equation. Your total cost is your $100 on the left. That's the money. How many cans C can you purchase? Let's go back to 5th and 6th grade. And you know what? I know it's I'm in 5th and 6th grade. My daughter is doing equations right now, and she's in 3rd grade. So this is a 3rd grade question. How do we undo multiplication? Yep. So then we go into our calculator and we divide, and then we have to ask yourself 100 divided by 0.75. If I could type in the decimal here, divided by 0.75. What do I round that to? How many cans can I purchase? 134 or 133? 130 what? 133. Because what would a 134 do? Put you slightly over the $100 that you have by 50 cents. Probably have 50 cents, but math-wise, you can only do 133 cans. Okay. That right there, all that we just kind of ran through, that's your quiz, that's your test. If you can basically answer those out, you're looking fine for the last 2 things. So what we're doing today is finishing things up. You're finishing up that assignment, and then you're getting out Matthew, and you're finishing up Matthew through Unit 4.